All right, so we talked about side, angle, side, and then today we're going to talk about 3 more proofs. So today we're going to talk about ASA, which is angle, side, angle congruence theorem. So 2 angles and an included side. Remember, included means the side between the angles. Okay, so it has to be included in the friendship of the angles. It has to be in between the 2 angles. So 2 angles and the included side of one triangle are congruent to 2 angles and an included side of another triangle, then the 2 angles are congruent. Okay? 2 triangles are congruent. But again, that's just a lot of words right now. So let's put it into like something we actually know. So first we have angle A. And angle A has 1 arc. Well, which other angle in the other triangle also has 1 arc? Angle D. So because both of them only have 1 arc, then angle A is congruent to angle D. Okay? And then if we go, we're looking for a side, right? Because angle, side, angle. Well, we note that sides are congruent by dashes. Okay, and the first sides that are congruent is going to have 1 dash. So line AB has 1 dash. And on the other triangle, DE also has 1 dash. So those are congruent to each other. So line AB is congruent to line DE. Okay? And then we need another angle. And then angle B has 2 arcs. Well, angle E also have 2 arcs. So therefore, angle B is congruent to angle E. Since we have an angle on the left side, the left triangle that's congruent to an angle on the right triangle, we have a side that is side on the left triangle that's congruent to the side on the right triangle. And then we have an angle on the left triangle that's congruent to the right triangle. Then therefore, triangle ABC is congruent to triangle DEF. Okay. By angle, side, angle. Okay. So let's go to number 2. It says given line JK is parallel to line LM. Remember that these little symbols right here mean parallel. Okay. Which that is our first statement, right? And it includes both of them because they're kind of the same thing. When you have 2 statements that are the same thing and have the same reason, you can put them into the same statement box. So line JK is parallel to line LM, and then line JL is parallel to line KM, and our reason is given. Okay? Remember that our first reason will always be given because you can't start one of these problems without being given something. Okay? And then because we have parallel lines, how do we note that the lines are parallel? What symbol do we put on the lines? You should be saying we put arrows, or some people call them triangles. So JK is parallel to LM. Okay, so that's my first set of parallel lines. And we have an entirely different set, right? So we'll put 2 arrows since it's another set. JL is parallel to line KM. Okay? And whenever you're given that lines are parallel, you should know that you're going to use angle relationships. Okay? Because we learned in Unit 3, we have parallel lines, and it's cut by a transversal, we'll use angle relationships. Okay. So therefore, if I were to extend these parallel lines, then the line in the middle, this line right here, is our transversal. Okay, so our angle relationships are really going to matter on that transversal. Well, let's look at it. Okay, we're given statement angle JKL is congruent to angle MLK. But really, what angle are they talking about? Okay, we learned in Unit 1 that we can name angles by 3 points. but the point in the middle has to be the vertex. Okay? So JKL. The one in the middle is the K, right? So if I were to connect those dots, it would look like this. That means it's this angle right here. Okay? And then is congruent to MLK. Well, MLK, which point was in the middle? What point did I say second? L. We would connect those dots. It'd be right here, right? So it's talking about this one right here. So those are congruent to each other. And we know with proofs, our two relationships that we know will either be corresponding or alternate interior. So now you have to ask yourself, are these on the same side of the transversal? No, they're not. So they're not corresponding. They're on opposite sides of the transversal, right? This one's on top of the transversal. This one's on top of the transversal, and this one's on the bottom, right? So therefore, since they're on opposite sides of the transversal, they are alternate, and they're in between the parallel lines, so they're alternate interior angles. Okay? Then we're given angle JLK is congruent to angle MKL. Okay, so let's go look at that. So angle JLK, which one did I say second? L. And since this is the second set of angles we're talking about, we should put two arcs. Okay? So JLK is congruent to MKL. So which one did I say second? K, right? So we should put two arcs here. So angle JLK is congruent to angle MKL. And remember, this is my transversal. What's the relationship between those blue angles? Are they on the same side of the transversal? No, they're on opposite sides of the transversal. So therefore, they're alternate interior angles. Okay, so we were able to derive these two answers right here, these two boxes, from that the lines are parallel. Okay, but they don't give us anything else, and we can't derive anything from these. Also, derive means to get something from something, okay? We can't get another answer from these. So when you can't derive something from what's given, you then have to look at the diagram and see what you know. Remember, you cannot assume midpoint, okay? It has to tell you that a point is the midpoint of the line, so you can't assume that, and you can't assume an angle bisector, okay? So what in the diagram can we just know just by looking at it? Well, don't we have triangle JKL and triangle LMK? Don't they share a side right here? So they share a side. The side is congruent to itself, right? You should be saying yes. And look, that is literally our fourth statement. Line KL is congruent to line LK because it is congruent to itself by the reflexive property. Anytime you have two triangles that are sharing one side, you will have reflexive property, okay, every single time. So then our last statement is what we're trying to prove, right? Triangle JKL is congruent to triangle MLK. Well, let's see how, okay? So when we look here, let me erase these parallel lines marks, my arrows. We have an angle, a congruent side, and then another angle, right? Same thing over here. So therefore, we have angle side, angle, and we have angle, side, angle, then those are congruent. Okay? Let's move on to number 3. Let's see what we're given. Okay, we're given that angle BAC is congruent to DEC. So the first thing that we're given will be our first statement. So angle BAC is congruent to angle DEC. And what's always my first reason? It's given. I cannot start these problems without being given something. And once you write those things on the truth table, we go mark them on the diagram. Okay? So it says angle BAC. Which angle is it talking about? It's talking about A over here because A was in the middle. Okay? And then it's talking about, it says angle DEC. Well, which one was in the middle? E. So we draw an arc around those. Okay? So I drew on the diagram. Let's see what else I can get. Can I get something that will help me from angle BAC is congruent to angle DEC? No, I can't derive anything from this. Okay, I can't get any new information from this. An angle is just congruent to an angle, and that's all it is. It is what it is. So when that happens, we go see if we're given something else, which we are. We are given that C is the midpoint of line AE. So that's my next statement. C is the midpoint of line AE. I know that is, again, it was given. They told me it was true. And once I write those things down, we go put it on our diagram. Okay? So C is the midpoint of line AE. Okay, so that's one that matters. Now what happens when I have a midpoint of a line? Midpoint means middle point. Okay, that point is straightly in the middle. So it splits that one line into two congruent lines. So therefore, AC is congruent to CE. And because I was able to derive that from what was given, I was able to get new information about the diagram from what was given. That's my new statement. That's my next statement. So line AC is congruent to line CE. Okay? And why is that? How did I get, so why is line AC congruent to line CE? Well, how did I come to that conclusion? Came to that conclusion after I was told that C is the midpoint of line EE. So therefore, the reason is definition of midpoint. Okay. Now, can I derive anything from AC is congruent to line CE? No. It just is what it is. There's nothing else I can derive for it. Did they give me anything else given? No, I've already stated what they gave. I put in the truth table and I drew it on the diagram. So now we have to look at the diagram and see what else I can derive. Remember, we cannot assume we cannot assume a midpoint. It has to tell us, which I already did, but we use that information. And we can't assume angle bisectors. We also can't assume alternate interior angles or corresponding angles unless they give me some lines are parallel, which they haven't told me that any of these lines are parallel. So really our only option is vertical angles, which we do have vertical angles, right? It's angle BCA and angle ECD. Those are vertical angles. I draw two arcs around them because it's my second set of congruent angles. Okay? And also the reason why I don't write angle C is congruent to angle C, because remember from unit 1, we can only write one letter or one point for congruent angles if it's the only point at that vertex or only angle there, which is not. We have two, right? So therefore, angle BCA is congruent to angle DCE. And again, I had to make sure that C is in the middle here because it's talking about that one. Okay, it's talking about the vertex. So how did I get that angle BCA is congruent to angle DCE? Because they're vertical angles. Okay? So we look, we have an angle, we have a side, then another angle. Same thing over here, right? So therefore, since I have an angle, side, and another angle, triangle ABC is congruent to triangle EDC by angle, side, angle. Okay? All right, so we talked about angle, side, angle. Now let's talk about angle, angle, side congruence theorem. So this time, if we have two angles and a non-included side, so included meant that it had to be in between the two angles, right? Well, non-included means it does not have to be in between the two angles. Okay, it can be outside or beside it. Okay, so if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the two triangles are congruent. Okay. So therefore, first, I need an angle, right? So what's my first angle on the left triangle? Angle A. And angle A is congruent to what angle? Angle D, because they both had one arc. So if angle A is congruent to angle D, okay, then I need another angle, right? So the angle next to it. So angle B, because it has two arcs, is congruent to what other angle? Angle E. So angle B is congruent to angle E. And then finally, we need a side, okay? We need a side that's not in between the two angles. It has to be outside the two angles. So therefore, we have line BC is congruent to line EF. So line BC is congruent to line EF. Okay? So since we had an angle was congruent to this angle, another angle was congruent to this angle, and the side not included or not in between the two angles were congruent, then triangle ABC is congruent to triangle DEF by angle, side. Okay. And again, this is just a little reminder. Non-included means I side opposite the angles, or I just like to say not in between the two angles. Okay. So let's do an example. We are first given that line YZ bisects angle WYX. Okay, so that is our first statement. The first thing that we're given is our first statement. So line YZ bisects angle WYX. Okay, and the reason, of course, is that it was given. So once we write those down, then we go mark it on our diagram. Okay, so let's go look at it. So it says line YZ, which is right here, bisects angle WYZ. Okay, so that's the angle. Since it's bisects, remember bisects means two sections, right? So line YZ splits angle WYX into two sections, two congruent angles. Okay? Well, which two angles? This one and this one. So take a second. I know it's been a while since we named angles by 3 letters. But what angle is on this side? Okay, which angle is this one? Well, y is in the middle, right? It's really like by y. Y is the vertex there. So it has to be in the middle of your three letters. So your options are angle WYZ or angle ZYW. And both of them are correct because y is in the middle. Okay, so just pick your favorite. I'm going to pick angle WYZ is congruent. Well, what's the angle on the right side? Again, y is in the middle. So your options are angle XYZ and angle ZYX. Okay, and again, just pick your favorite. Angle XYZ. And how did I know that? Well, how did I come to that conclusion? How did I say that those angles were congruent to each other? Well, it was right after they told me that line YZ bisects an angle, right? So therefore, it's the definition, I'm going to abbreviate there, of angle bisector. And again, I wrote something, they gave me something, and I was able to derive something from it, okay? I was able to get new information about the diagram from what they told me. So that's why that's second, okay? So can I derive or get new information from angle WYZ is congruent to angle XYZ? No. So we go look to see if they gave us any more information, which they did. They said angle YWZ is congruent to angle YXZ. Okay, so let's go look at what they are. So it says angle YWZ. So YWZ, well, which angle is that? It's this one, it's angle W. So we put 2 arcs because it's the second set of congruent angles. And what's my other one? Well, it says YXZ, right? So YXZ. It's talking about the X over here, okay? So we put 2 arcs around the X. So those angles are congruent, and how did I know that? Well, they told me, so it's given. They told me that information, so I believed it to be true. All right. Can we derive anything from this angle as congruent to this angle? No. So we go see if they gave us any more information that we haven't used. Nope. We've used all the information they told us. So then we go look at our diagram kind of as a last resort. Again, we cannot assume midpoint. Okay, they have to tell us that y is the midpoint of, they have to tell us that z is the midpoint of wx, which they don't, so we cannot assume that that's a midpoint. They can't assume angle bisector, which they've already told us. But again, I have 2 triangles here, and they both share a side. Okay, so that side is congruent to itself every single time. So YZ, line YZ is congruent to line YZ. And when a side is congruent to itself, that's by the reflexive property. Okay? So we go look, we have an angle, another angle, and then a side, right? Same over here. We have an angle, and a side. So therefore, triangle WYZ is congruent to triangle XYZ by angle, side. Okay? Number 5 is a little bit harder. Okay? But first, let's see what we're given. We're given that angle ABC is congruent to angle CED. Again, we're given that, so that's the reason. Then once we write that down, we go mark that on our diagram. Okay, so angle ABC is congruent to CED. So this angle and this angle are congruent because ABC. My second point was B, and then CED. My second point was E. Okay? So I marked on the diagram. We can't derive anything from the statement, so we move to see what else they gave us. They also told us that line AB is parallel to line CE. Okay? And it was given. Once we write that, we go write it on our diagram, right? And how do we write the lines are parallel on a diagram? We draw our arrows. That wasn't a very good arrow. So we draw arrows. And honestly, I'm going to extend my lines. It just helps me see like what we're talking about because lines go infinitely in every direction, right? So with parallel lines, a line intersecting two or more lines are transversal, right? So therefore, this is a transversal, this one's a transversal, and then this one is a transversal, right? But which one of them will give me alternate interior angles or corresponding angles? Well, that would be this one, the very bottom one, okay? And do we have alternate interior angles? Do we have angles on the opposite side of the transversal? No, but we do have two corresponding angles because they're on the same side of the transversal. They're on the top side of the transversal, and they're in the same position, okay? So therefore, angle ACB is congruent to angle CDE by corresponding angles. And I had to write 3 letters, 3 points for angles because this point was not the only point. This angle was not the only angle at that vertex. Okay. We learned all that in Unit 1. And again, because I was able to derive this from the lines that were parallel, that was my next statement. Okay. But I can't derive anything else from the angle being congruent to the other angle. So I go back to see what else they gave us. And they told us that C is the midpoint of line AD. Okay. And how did I know that? Well, they told us that. So the information was given. And once we write that down, we go mark it on our diagram, right? So C is a midpoint of line AD, okay? And what happens when we have a midpoint? It splits that one line into two congruent lines, right? So therefore, line AC is congruent to what other line? Line CD. And again, I was able to derive that fact from what they told me. So that's going to be my next statement. So next statement is AC, line AC, is congruent to line CE. CD, excuse me. Line AC is congruent to line CD. And how did I know that? Definition of midpoint. I was able to get that information after they told me that C was a midpoint. So the reason is definition of midpoint. Okay? Now let's look at what we have here. Okay, I'm going to erase these marks. I'm going to erase this midpoint so I don't get confused. Okay? We have this angle is congruent to this angle. This angle is congruent to this angle. And this side is congruent to that side. So therefore, we have AAS, AAS. Angle, angle, side. And we know that when we have angle, angle, side, angle ABC is congruent to triangle CED by angle, angle, side. And also, I'm sorry, I know I said angle ABC, but I really meant triangle ABC. Okay? All right, we are almost done. The last proof that we are going to learn about today, the last theorem, is the hypotenuse leg theorem. The hypotenuse leg congruence theorem. Okay? So it says if the hypotenuse in a leg of one right triangle is congruent to the hypotenuse in a leg of another right triangle, then the two triangles are congruent. Now, before this theorem, we didn't have to specify what kind of triangle it was, right? Could have been a right triangle, it could have been an acute triangle, and it could have been a right triangle. But because the theorem is hypotenuse leg, you get hypotenuse from a right triangle, okay? Hypotenuse is hypotenuse. Okay, you get those from right triangles. And if you look at our little note here, the hypotenuse is the side opposite the right angle, okay? So if you draw an arrow coming away from the right angle to the opposite side, you hit this line. So this one's a hypotenuse. Same here. Draw an arrow starting from the right angle to the opposite side. This one's a hypotenuse, okay? So if hypotenuse, so what are my two hypotenuse? Line BC and EF, if they are congruent, which they are in this case, because they have the singular dash. And then a leg, well, leg is a side adjacent to the right angle, right? And what does adjacent mean? This is Unit 1 vocabulary. Adjacent means right beside each other, right? So here's our right angle. So this one's a leg, and then this one's a leg. Same thing over here, right? So if a leg of one triangle is congruent to the other leg, well, AB here is congruent to DE, or BA is congruent to ED. So if a hypotenuse is congruent to another hypotenuse and a leg is congruent to another leg, then the triangles are congruent to each other by hypotenuse leg theorem. So triangle ABC is congruent to triangle DEF. Okay? So let's put that into practice now. Okay. So we are given that triangle LMP and triangle MNP are right triangles. Again, that's very important, okay? You cannot look at the diagram and just assume that they are right triangles, okay? Because right triangles are 90 degrees. Well, it'd be hard to see if the triangle was 91 degrees or 89 degrees, okay? So it has to either state it or give you the boxes, okay? Like right here. But thankfully, they told us that they're right triangles, so that's our first statement, and our reason is given. Okay? That's the only thing that I can get from that, so we move on to the next thing they told us. The next thing they told us was line ML is congruent to line MN. And of course, that is our next statement right here. And the reason is that it was given. They told us the fact, so we believe it to be true. And once I write that down, I go mark it on my diagram. So line ML is congruent to line MN. Okay? Now, can I derive or get new information about the diagram from those lines being congruent to each other? No, I can't. So I go see if they gave me any other information. And sadly, I've used up all the information that they told me. So now I gotta resort to looking at the diagram. Okay? They didn't tell me if I had a midpoint, so I can't assume that two lines are congruent. Okay, they didn't say that any other two lines were congruent. Our last option is reflexive property, which we do have here. Okay, because triangle MLP M, and P all share this side right here. So if they share one side, then that side is congruent to itself by the reflexive property, which was our third statement. Okay? So if we go look over here, which line is my hypotenuse on this left triangle over here? Remember that hypotenuse is the side opposite the right angle. So this one's a hypotenuse, and then MN is also a hypotenuse. Okay, that's abbreviation. And which two lines are my legs? Our legs are adjacent to the right angle. So LP is a leg, MP is a leg, and NP is a leg of the other triangle, and then NP is also a leg. So we have a hypotenuse is congruent to the other hypotenuse. And the leg was congruent to the other leg. So therefore, the triangles are congruent by hypotenuse leg. It's probably like one of the easiest theorems there is. Okay. So example number 2, we are given the triangle WVX and triangle YZX are right triangles. I'm running out of room. Are right triangles. Okay? And I know that because it was given to me. Once I write that down, then I can go draw the angles on the diagram. Well, which two angles are right triangles? You should be saying angle V and angle Z. Because if we look, angle W is clearly a acute angle. So is angle X and angle Y. So therefore our options are Z and V. Okay? So I can't derive anything else from that information. So let's go back to see what else I was given. So it tells me that line WV is congruent to line YZ. So that's my next statement. So WV is congruent to line YZ. I know that because it was given. Then, of course, once I write all that down, I can then go mark it on my diagram. So WV is congruent to line YZ. I put a singular dash at each one. Can I derive any more information from this statement? No, it just is what it is. Okay, so we move on and see what else they have given us. Well, then they tell us that X is the midpoint of line WY. So that's my next statement. X is the midpoint of line WY. Okay. And the reason why I know that is because they told me it. It was a given statement. And once I know that, I go look at the diagram and mark it. Okay. And we know we can always get something. We can always derive something when we're told a point is the midpoint. So let's look. So that X is the midpoint of line WY. Okay. So what happens to line WY with the midpoint? It gets split into two congruent sides, right? So line WX is now congruent to line XY because we had a midpoint. And of course, that's my next statement because I was able to derive something. So line WX is congruent to line XY. And how did I know that? Well, how did I get that information? It was after they told me that X is the midpoint, right? So therefore, our reason is definition of midpoint. Now we have to see if we have a hypotenuse congruent to the other hypotenuse and the leg congruent to another leg. Well, let's look at which one is the hypotenuse. So remember, hypotenuse are the side opposite the right angle. So we draw an arrow starting from the right angle to the other side. Well, that's WX. So WX is hypotenuse. What about the other triangle? We start an arrow starting from the right angle to the opposite side. It hits XY, right? So XY is hypotenuse. And they're congruent to each other, right? They both had 2 dashes because I was supposed to write 2 dashes. Okay. And then do we have a leg? Do we have a side adjacent or right beside the right angle? Yeah. We have WV is congruent to YZ. So we have a hypotenuse is congruent to another hypotenuse, and the leg is congruent to another leg. So therefore, triangle WVX is congruent to triangle YZX by hypotenuse leg. And that's it.